So sequencing models and related problems. So what is sequencing? Sequencing model problems involves the determination of an optimal order or sequence of performing a series of jobs by a number of facilities that are arranged in a specific order so as to optimize the total time or cost. So sequencing models with this particular type of definition, you'll be able to now justify, or you will be able to analyze that such type of problems of sequencing model are the minimization type of problem, right? So here what we are going to do is we are going to minimize the total elapsed time, and indirectly we are also going to minimize the cost. Sequencing problem can be classified in two groups. This is the group one, and the explanation goes as follow. We have n different jobs to be performed, and each of these jobs require processing on m different types of machines. The order in which these machines are to be used for processing each job is known. So for group one type of problem, what are the known things? We know what are the number of jobs with us. We know what type, how many number of machines are available with us. We also know the processing order, right? So the order in which the jobs are to be processed, the order in which the machine is to be used for processing is also known to us, right? The another thing what we know is the processing time of each job on each machine. So that is also known to us. So input in this particular case is the number of jobs, the number of machines, the processing order of the machines, and lastly is the processing time of the machines, right? So this is the processing time of each job on each machine is known, right? So with this type of input, what is the problem that we have to solve is we need to find a proper sequence of job which minimizes the total elapsed time. So this is our this is our main objective, right? So what is the objective here? It is the minimization of the total elapsed time, along with what it is also telling us that we have to minimize the idle time for the machines. Here if you ask any no here if you ask yourself regarding what is the objective function of the sequencing, so objective function of the sequencing is to minimize the total elapsed time and to minimize the idle time of the machines. And if you ask yourself what are the constraints of your sequencing type of model, so what are the constraints? So constraint is the number of jobs that we have, constraint is the number of different types of the number of machines that we have, and the processing order we cannot change. See the variables that we cannot change are the constraints, right? So what are the variables that we can't change? It is the number of jobs that we have, the number of machines that we have, and the processing order. These are the variables that we can't change, and hence these variables are acting as a constraint. So for a sequencing type of a problem, objective function is to minimize the total elapsed time along with the minimization of the idle time of the machines, and the constraints are the number of jobs, number of machines, and the processing order. So we have also seen the meaning of the few terminologies. We have seen what is the total elapsed time, yes. So total elapsed time, if you recall, so it is the time period from start of the processing of the first job on first machine to the completion of the last job on the last machine. So it is equal to the processing time plus idle time on each machine. So very important definition, because this particular total elapsed time is the only thing that we need to minimize. So this should be understood. What actually we are going to minimize is to be understood properly. So we are going to minimize the time period from the start of the processing of first job on first machine to the completion of the last job on the last machine. So we came across one of the terminology which was processing time, and here we have what is the actual meaning of the processing time. So what is the processing time? It is a time required by a job on each machine, right? So for each so for if we consider any job, it will be requiring some time on a particular machine. So that time is nothing but a processing time. We have also no, we also came across one of the terminology, that is the idle time. And what is the meaning of the idle time? It is the time for which the machine remains idle during the total elapsed time. The the idle time of the machine literally means that the machine is waiting for a job. If the machine do not have a job, it we can't run that machine, right? So for that particular time, we'll have to keep that machine idle, and hence it is called as the idle time, right? So now we have also seen what happens if we try to solve this problem manually, right? So if we try to solve this problem manually, it will be no, it will be seeming to be an impractical and impossible task. Why it is seeming to be impractical and impossible task, even with the small values, like if there are four jobs to be processed on each of the five machines, the total number of the different possible sequences comes out to be how much? It comes out to be 79,62,624. How come this figure came? It came from this particular this particular calculation. It is 4 factorial raised to 5. So even with a very small no so small number of jobs and few number of machines that we have, the total number of possible sequences are coming to be very very huge, and hence this may seem impractical and impossible, right? But then now here no what we can say here, we can justify the need of the sequencing model. So why the sequencing model? Because we cannot do, or we cannot focus upon all 79,000 79 lakh 62,624 different possible sequences. We will have to minimize the we'll have to find out that optimal sequence with less efforts, right? So here sequencing model is going to help us with that particular thing, right? So that is the importance, or that is the need of your sequencing model, right? We have also we have also seen what is a group 2 type of problem that we we may come across in case of sequencing. That is in group 2 we have the no, the second group of problem deals with the job shops having a number of machines and a list of tasks to be performed. Each time when the task is over, we'll have to think which is the next task that is to be taken on the machine. So now that particular list will go on changing as the fresh orders are continuously being received. So this is your group type of problem. Group type of problem is more complicated problem, and we do not have it into our syllabus. So what we are going to focus is upon only group 1 type of problems, where we know what are the different types of jobs that we have, how many number of machines that we have, the processing order for the machines is also been given, the processing time of each job on each machine is also known. And what we are interested in, we are interested in finding out that optimal sequence which reduces the total elapsed time along with the minimization of the idle time. So that is very very important. So frequently no this question is asked in your examination regarding what are the elements of sequencing problem. So right, so we've seen what are the different elements. So the number of machine is one of the element. It refers to the number of service facilities through which a job must pass before it is completed. So normally it is being denoted by M, right? We have a processing order. If we have like we have three machines, and it has been told us that the job should be first processed on machine A, then on machine B, and then on machine C, then the processing order happens to be A, B, C, right? We have seen what is the meaning of the processing time. We have seen what is the meaning of the idle time, and we have also seen what is the meaning of the total elapsed time. So all these are your elements of sequencing problem. There is one more element that we have, and that element is called as the no passing rule, right? So no passing rule is related with your processing order. So if the processing order is been given as A, B, C, we cannot no we cannot skip any machine in between. We'll have to pass the job from for first on A, then on B, and then on C. So we cannot skip B in between, or we cannot skip A and directly start from B or C, or we cannot say that our job is completed with only two machines A, B, when we have a sequencing order of A, B. We have a processing order of A, B, and C. So how many type of different no, what we can say cases that can be solved with the help of a sequencing model are listed here. So analytical methods are developed for only this five type of simple cases, right? So we have first case as n jobs one machine problem. We have n jobs two machines problems, and we have n jobs three machines problem. We have two jobs m machines problem, and we have n jobs m machine problem. So what we have for the syllabus is n jobs one machine problem, n job two machines problem, n job three machines problem, and n jobs m machine problem. So this particular is not for your syllabus, right? We have second, third, and fourth. Second, third, and fifth for your syllabus. Again, your fourth is not the part of the syllabus, right? But we are going to see our first case, that is n jobs one machine problem, to to develop our understanding regarding these type of numerical, right? So nextly, when we start we have also seen the assumptions in the sequencing problem. So what were the assumptions in the sequencing problem? The very first assumption is that only one operation is carried out on a machine at a particular time. So this is a very basic assumption that we that needs to have, and that we need to have, then only we can reduce the complexity in the sequencing problem, right? Each operation once started must be completed. We cannot keep an operation incomplete, right? Once we have started that operation, it must get completed, and then we'll be taking next job for that, for the operation purpose. An operation must be completed before its succeeding operation can start. Again, indirectly the same thing. The operation must be completed. We cannot keep the job as incomplete, and even the operation as incomplete. So that is to be understood. Only one machine of each type is available, right? So this is also what I was talking about, the constraint that we have. We do not have like 10 machines of same type. We have only one machine of one type, so that we'll have to wait till the process on that machine for a particular job finishes. A job is processed as soon as possible, but only in the order specified, right? So as soon as the machine gets empty, we are going to put a job for the processing on it, but we are but the processing order is to be followed. Processing times are independent of order of performing the operations, right? So the processing times that we have given are independent of order of their performance on the machines. The transportation time, that is the time required for the transportation of the jobs from one machine to another, is negligible. So we cannot say that one machine is being kept in Pune, another is being kept in Mumbai. So we'll have considerable time of like 4 5 hours for the transportation itself, right? So the assumption here is that the all the machines are in the single workshop, and then we are going to start with the sequencing process, or then we are going to start with the process. Jobs are completely known and ready for processing when the period under consideration starts. So again, with this particular assumption, we have no we have eliminated the possibility that the operator do not know how to process on that job. And again, we have eliminated the possibility that now that job is to be processed, the machine is no the machine is not ready for processing. It has undergone some maintenance. So this possibility is being eliminated, completely eliminated. We know that the jobs are completely known to the process, to the operator, and again, the machine is ready for the operation as soon as the job is received. The cost is in the cost of in process inventory for each job is same, uh, and it is negligibly small.